Okay, so hello everyone, and welcome. Thank you so much for joining us today. This is the very first session of the new XR research event series that ICXR has begun. So if you are someone who's curious about extended reality or XR research, or if you just want to share your own work or just get to know research that is happening in this sphere, then this is definitely the place for you to be, and we are very happy to have you here. So, I just wanted to explain what the series is about. So, this is an event for exploring, learning about, and discussing XR research. So, each session will run for about 1 hour, and the time of each session may change each month depending on the speaker's time zone. So, it may not be in the same time slot as this session for the next few or upcoming ones. I do want to let everyone know that this session is being recorded and it will be uploaded to the ICXR YouTube channel. So if you have to leave halfway through or if you just want to go back and rewatch, then you can totally go ahead and do that. I will go ahead and talk about the agenda for today's session. So for the first 30 minutes, I will introduce this event to everyone, which I'm currently doing, and then I will also turn it over to the speaker, and we will have a presentation from the speaker. The speaker would usually be an XR researcher, an industry professional, a professor, or just a community member on an XR research platform. And after this presentation, we will have 30 minutes for the other three things on our agenda. So we will have a Q&A with the speaker, and then we will have a paper discussion. So this is where each person ideally would bring an interesting paper that relates to the theme that I will show in the next slide. And the idea is that we can share papers with each other and talk about research pertaining to the theme. Lastly, I will conclude the event with some closing remarks as well. So, just to talk about the theme and today's event. So, today's theme is avatars and agents in social VR. I'm your host, I'm Vaishnavi. I'm a data science major at the University of Texas at Dallas, and I'm an executive board member at ICXR. And our speaker today is Sam Thompson. Sam is the president of ICXR, and he is a PhD student at the University of Cambridge. And Sam will begin with a talk based on today's theme. So, without further ado, please join me in welcoming Sam. And Sam, the stage is yours.
I think for me to share my screen, I think you need to stop sharing, sorry.
Okay, yeah, no worries.
Perfect.
There we go.
Great, thank you. Wait, can you see my screen all right?
Yes, I can.
Great, cool, I'll get started then. Thanks so much for that introduction, and nice to meet you all. My name is Sam Thompson, and I'm a PhD student at the University of Cambridge. And today I'm going to talk to you guys about avatars and agents in social VR, and talk a bit about what my research has been and some of the past projects I've worked on as well. So as a bit of an overview for today's talk, first I'm going to get started with an introduction, just talking a bit about who I am. Then we're going to get started with some background, some concepts that might be useful later on in the talk. Then after that, we're going to get started with my honours dissertation, and I'll talk a bit about the project I did at the end of my undergraduate studies. And then finally, to conclude, I'll talk a bit about what I've been working so far on in my PhD. I've just come to the end of my first year, so there's some stuff to talk about, but we'll get to that when we get to that. Right. Cool. So as a bit of an introduction, as I mentioned, I'm a PhD student at the University of Cambridge. You can see in the top left of my screen there, there is a photo of myself with some of the people at the Cambridge VR and AR Society there at the Freshers Fair. And then in the photo below that as well is a big group meetup of ICXR at the AWE Expo, which is really cool to meet all the people there. So a bit about who I am. As I mentioned, my name's Sam Thompson. I'm a researcher in XR. I'm originally, if you can tell from my accent, from Auckland in New Zealand. And I grew up there, did my undergraduate studies there. And about a year ago, I moved over to the UK to complete my PhD. And I'm supervised by Professor Thomas Binet. As you can see on the left there, that's a group photo of some of the University of Auckland VR Club execs back in 2024. That was just before I moved as well. So it's great that I could say goodbye to all those people there as well. There was like at one of my leaving parties, which is really nice as well. If you couldn't tell already, I'm quite involved with lots of university XR clubs. So I was the president of the University of Auckland VR Club back in 2023 when I was finishing up my undergrad studies there. Throughout this past year, I've been fortunate enough to be the president of ICXR. And more recently, I've become the co-president of the Cambridge AR VR Society as well. So it's been a fantastic experience as well. I've also been super fortunate enough to attend multiple conferences so far over the past year. Back in 2024, a couple of weeks into my PhD, I attended Kai Play in Finland, and I was able to present a paper there, which was a super great experience. Then a bit later on in May of this year, I went to Eurographics, where I was fortunate enough to present a couple of papers there. And then I was also able to go to AWE a bit more recently. And there I got to meet some of the ICXR people in person for the first time, which was really special. Talking a bit about some of my research interests. So I'm really interested mainly in 3D graphics and games predominantly. And so I see 3D graphics essentially as a way of us to mirror reality. And games and interactive media allow us to kind of immerse ourselves in this 3D world. So when I started learning about VR, to me it was natural, where VR essentially allows you to take this a step further and fully immerse yourself in these 3D worlds there. And then social VR is a no-brainer for me, where it allows you to kind of link all these individual experiences over just to the immersive nature of VR as well, which is amazing. Cool. So a bit of background before we start getting into the actual research about what I've been doing. This talks about avatars and agents. So what are avatars and agents in social VR? So when we talk about avatars, what I mean by that is virtual representations of 3D users' bodies. So they can be self-avatars. So say you're playing a VR game and you look down and you see your arms or your hands or a full body. That is your self-avatar. However, they can also be avatars of other people as well. Say you're playing a multiplayer game and you see these 3D bodies walking around that have like names over the top of them sometimes, and you can tell that those are supposed to be real other players playing, then that's their avatar as well. Typically, they can be customized as well. And in such cases where they can be customized, they typically make up a large part of someone's virtual identity, because people are able to express how they want to be seen by other people through this avatar. So it's really important. Then we have agents, which are very similar. However, they're avatars that are not controlled by humans. So typically they're automated. More recently, they've been controlled by things like AI or large language models that do a lot of the heavy lifting there. But they can be controlled by any automated system, really. So why do I find this interesting to research? Well, there's this effect called the Proteus effect, which is the self-conforming behavioral effect, where how an avatar appears for someone actually influences how they behave. It's this really strange psychological phenomenon where, for example, it's been shown in some research papers in the past that if you have in VR an avatar of yourself but has larger muscles than you typically do in real life, you can actually lift the same amount of weights but for a longer period of time on average. So it has these real world physical effects on you, even though it's just simply changing how they look. And so this is really interesting, and researchers have been looking at this for a little while now. Typically, in the past, they were looking at it for more specific body parts. You might have heard of what's called the rubber hand experiment, where participants would put their hand down on a desk, and it would be covered by some kind of obstacle, and a rubber hand would be placed where the user could see it there. And this rubber hand was set up so that it would look like a real physical hand that belonged to the participant. And then they would do some activities where they would make the user think that the rubber hand was their own. And at the end, they would typically stab the rubber hand. And the user would kind of jump and be like, ouch, that felt like it hurt, but it didn't. And even though they didn't touch the real hand. So there's these connections that having this avatar can actually bring into reality. And this was found to translate over to VR for full body avatars as well, which is super powerful. So I mentioned a bit about what impacts this. So self-avatars, of course, but also it's been found that other people's avatars affect your own behavior through the similar effect, including the avatars of virtual agents as well. So there's all these different variables happening at once, and no one really knows quite 100% of what's going on there. So I find it really interesting to research. Another concept that's going to be really important to understand is this concept of behavioral realism. So essentially, if something behaves realistically, then it has a high sense of behavioral realism. In VR, I'm sure as a lot of you are aware, things can behave not super realistic from time to time, and this can start to break that effect down if people notice it too much. So if something has a high sense of behavioral realism, then that goes a long way for having this effect there. And it's very important for users to embody their avatar. What does that mean, though? What does it mean for a user to embody their avatar? Well, that's another core concept I'm going to talk about, and that is the concept of embodiment, where it's kind of a measure of how connected a user is to their body there. And I'll talk a bit more in detail about this in a second, but just know that this is also impacted by non-self avatars, so other people's avatars, and the environment that you're in as well. Cool. So looking at embodiment, so there's three main aspects that make up this concept here. We have self-location, body ownership, and agency. You can think of self-location as this understanding that your body or this virtual body is in a 3D space. For example, if we say the sentence, "I'm moving my arm," say just from side to side, then the fact that you're saying "I'm moving my arm" implies that you have this concept of self-location for the virtual body, where you're acknowledging that the arm is moving through physical space. Then we have body ownership, which is a bit more self-explanatory, where you just feel like you have ownership over this body. So in that sentence, "I am moving my arm," you're saying "I'm moving my arm," and the "my arm" aspect of that indicates that the arm belongs to yourself, so you have ownership over that body. And finally, we have agency, which just simply means that you are in control of this body as well. And so when you say "I'm moving my arm" as opposed to "my arm's moving," you're indicating that you are the one in charge of that action and it's not happening out of your control there. So those are the three concepts that together make up embodiment. Great. So we've gone through some of those core concepts now, but what have I actually done in my research with these concepts? So we're going to be talking a little bit now about my honours dissertation work as well. So what was this dissertation about? So this project was done for my final year of my degree, my fourth year, back in the University of Auckland. And what I did to begin it was I conducted a literature search on avatars in social VR. And I tried to find out, first of all, what would be an interesting project to do, but also where there is a gap. So I found a gap where there's, at the time especially, and still right now is true, lots of work had been done on personalized self-avatars. So avatars that, as you'd expect, are personalized to the user. Typically, they look like the user does physically, and face tracking as well. And these areas had been done quite a lot in social VR research. However, they hadn't really been combined together. Now, I thought that if your avatar is personalized, typically that's done with your face, like a 3D model of your face is created. And inherently, face tracking morphs how that looks and plays around with that. So this intersection between these two technologies is really important to understand how they work together, and that hadn't been done before. So what I did was I created a networked XR application using the Unity engine to mirror a real-world conversation. And then from this, I conducted a user study trying to measure the difference in embodiment there. And I'll talk a bit more about that in a second. So, yep, as I was saying, I investigated the impact of personalized avatars and face tracking in social VR on embodiment, but I also measured some other variables as well. For the sake of time today, I won't go into those too much, but I did also measure things like intrinsic motivation and participant personality. The main research question that I was looking at is how is an individual's embodiment impacted by personalized face tracked avatars in a social VR experience? So to answer this, as I said, I created that Unity experience, and then I created the user study and conducted a semi-structured interview as a form of dyadic social interaction. So dyadic just meaning there's two people involved here. Using the Unity engine as well, I created a pipeline to create these 3D full-body avatars from a single photo of the participant, just from like a mobile phone, with face tracking as well. And this was a bit novel at the time, especially because a lot of the prior research required large arrays of cameras and special sensors on them and professional lighting conditions to get a good quality result. So one of my aims of this work, especially considering I didn't have access to this, was that I wanted to have something that worked with low-end hardware to kind of promote that accessibility of it there. So using the system, I conducted a user study and I personalized the avatars to all the participants as well. This was a bit of the pipeline of how it worked. As you can see, one of my friends helped out with this. So you can get the user's face here. I don't know if you can see my mouse or not, but you can get their face as an image taken on a consumer level mobile phone. And then manually, you can put down the feature points, the important feature points in the software called FaceGen that I used. And from that, it spits out this 3D model of the head with the texture, which was super useful. Then what the tricky part is getting that into Unity and in the avatar and hooking everything up together there. As you can see, there's no hair with this avatar, and the body is kind of generic. It doesn't really change too much outside of adjusting the size of the body based on the person's height. However, with the limited time and resources, that's kind of the limitations you have to make when you're doing this sort of stuff. So doing the study, each participant would do 2 conditions. The order of which they did it was randomized. And in the control condition, they had a self-avatar, which was generic, and the interviewer also had a self-avatar for themselves, that was generic but different. You can see the 2 different faces there as well, and both of those faces had no face tracking at all. In the experimental condition, it was different, where you had your own personalized self-avatar, and the interviewer, as you can see pictured here, had his own avatar personalized to himself, and face tracking was enabled. This is kind of an example of how it looked in the real world, in the lab, when we conducted these experiments, and how it looked in the Unity engine as well when we were running it. So you can see that the participants is put maybe about 1 meter away from the interviewer, and this matches up with the distance in real life as well. So because of that, we didn't have to do any over the internet voice transmission. We could just simply have people talking in the lab in real life, and that communicated fine across there. Great. So this project was mainly completed in 1 semester, and we had 39 participants in the user study. For some of the results, we found that there was an increase in embodiment of 41.6% with p-values of 0.19 and less than 0.001, sorry. So a statistically significant result there. And that was an increase in the experimental condition over the control condition. We also found that there was a correlation between the extroversion personality type and embodiment. Only a moderate correlation of about 0.35, but it was statistically significant as well. As well, we found that a large portion of people, over 80%, found that they just preferred the experimental condition. And a large portion as well of 2/3 found it more engaging in general. But not everyone. They found, though, that these people that enjoyed it more had an improved sense of realism in the experimental condition, an improved sense of immersion and social connection with the interviewer as well. As I alluded to before, it wasn't all perfect. So there was limited hardware that I used, as well as time to generate the avatars. All the avatars were generated on the fly once the participant entered the lab. And so we only had about 5 minutes-ish while they were doing all the pre-study questions to generate the avatar, which meant that it wasn't perfect. There's also some difficulty recruiting participants I had. So the gender imbalance especially wasn't very fair, and the age range was also quite small. So the results might not be super generalizable to a larger sample as well. Some participants found the experimental condition was a bit more creepy and therefore less enjoyable, which I think is quite fair, to be honest. If you're seeing yourself in a way that isn't generated super perfectly, especially if you have quite a lot of hair that's cut out with a random beanie, then it kind of makes sense that you might find it a little creepy with the face tracking as well. Additionally, the environment was chosen to be plain, and so it was just black darkness around so that the less influence or bias happening. However, this kind of just contributed to that feeling of creepiness and eeriness that these participants already had. So that was a bit of an issue there. As well, one of the limitations is that it was not a fully automated pipeline. So even though it was very fast to do, it still requires some human input as well, which is an issue if you want to do this on a larger scale. Right. So that was what I did for my undergrad, and then I've more recently started my PhD about a year ago, and I've moved to Cambridge, and here are some photos that I found I took in my first week or so of moving here. The weather was quite nice. It's not as nice right now. When I was thinking about the topic for my PhD, I wanted to do a very similar topic. My passion's still about social VR and avatars. However, I had a few different considerations this time. So my undergraduate studies was in computer science, and now my PhD is technically in engineering. So that allows me to be a bit more open with looking at resources from outside of academia and taking that into consideration. So what I wanted to know is, what is this difference here between academia and non-academia? So from a hobbyist and industry perspective, I wanted to know what people were creating online. what's been made open source and what are companies doing. In academia, I was really interested in what the cutting edge currently is as far as the literature shows, and where that disconnect is between industry and academia. If I could find some kind of topic that let me answer all of these with something interesting, then I think that's a pretty interesting topic for myself. That's where it led me to agents in social VR. So we've spoken a bit about avatars already. Now we're finally getting to the agents of avatars and agents here. So the main type of agents that I'm interested in and we'll be talking about for the rest of this talk are embodied conversational agents, or ECAs. So embodied conversational agents, as you might expect, are agents that have a body, so some kind of avatar that represents them, but they're also conversational in this sense that they can interact with a user verbally and non-verbally while displaying this virtual body. And it's essential here that they interact in real time, otherwise they won't be super useful for the real-time application purposes of social VR. There are some limitations though right now in the current state of academia with this topic. So there seems to be a lack of research, particularly in this kind of more recent ECA technology, simply because it's been developing so fast with the rise of more advanced AI models. So it's quite tricky for them to keep up with. As well, there's a bit of a disconnect between academia and non-academia, and I'll talk a bit more about that right now. So mainly there seems to be a lack of understanding about ECAs that exist in social VR. So people in academia aren't really talking too much about currently existing ECAs. They seem to make their own abstract one and then do a user study on it, and then that's that, it's left at that. However, there are some ECAs that currently exist right now, but they're not being spoken about or discussed in the literature. There also seems to be a lack of understanding about user perceptions of ECAs in VR, and in social VR in particular. So it's not super sure where people that use social VR are going to be the target audience for this. And if people don't understand how they're going to respond to it, then there's quite a large gap there, in my opinion. As well, there seem to be some conflicting results about what's most important when it comes to these ECAs. Is visual realism better, or is behavioral realism more important when it comes to promoting the embodiment of users based on these agents here? As well, lots of papers have different non-standardized capabilities of ECAs, so results can be quite difficult to compare across papers, even if they have similar performing ECAs. If they do different things, it's very difficult to actually compare them. As well, there's just a lack of understanding in general about how ECAs and humans interact in real social VR platforms. It's more seems to be about the technical side right now that are in the literature. So for example, there's this ECA that currently exists right now in VR chat called AI Jokin. And she is powered by a GPT model and was originally designed as a utility bot. So the creator made this bot just to do different types of things for events. However, over time, AI Jokin got more features and became more powerful and eventually into a full ECA that we know today. The creator also released some software called AI.com that you can use to create your own ECA in VR chat. I haven't used it much myself, but it seems pretty good. But this is an example of a bot that exists right now and is online most of the time that people can go and talk to in VR chat. And this just seems to be completely missed from the literature right now. So much so to the point where people are even making friends, or they claim to make friends with this bot here and actually seem to care for them, which is really interesting. So with all this said, what do I actually want to have been done by the end of my first year? What I wanted to do was aim to design some kind of prototype ECA in VR that can replicate social interaction with a human. I saw lots of existing ECAs that are around, like AI Jokin, for example, but all of them seem to have some limitations that creating my own prototype seemed to address a bit better, and I can kind of tailor it for my needs a bit more as well. For example, lots of bots that existed weren't super fast in their time for generating messages and responding, and that's one of the things I'm focusing on here. But I wanted to understand, first of all, how feasible it would actually be to create this. So I'd started with some iterative prototyping, and I've kind of come to the end of that now, thankfully. And I identified some design requirements for this prototype. So for the sake of time, I'll go through these pretty fast, but for the hardware, I just needed something that ran at least 72 FPS, did hand and head tracking, and was able and accessible for participants to use in terms of being a VR headset there as well. The agent was a bit more specified, where I wanted to create some kind of agent that had the ability to listen and understand what the user is trying to communicate with them, be that verbally or non-verbally. They must be able to communicate in a human-like manner. They must be able to understand the context of the conversation as well, and therefore interact with the environment accordingly. So not just with the user, but the environment around them. And they must be able to stay on topic and in character. LLMs typically have difficulty doing this, so that's one consideration. The agent must be able to perceive the environment and then remember this in memory. And the agent must be able to communicate with multiple users at once. And finally, it should be able to respond and do all of this in real time. Then the final design requirements were about the platform. Of course, this is social VR, so I want to be able to support multiple users at once interacting with this ECA. So we need to have different avatars at once, not just users, but also have their visual avatars represented as well. I need to be able to customize these. It's no good if I have no control over that as well. And the platform must possess security features to ensure that if I'm doing some kind of user study, I don't have a random person join partway through. As a bit of a summary, this is kind of the decisions I made in the end for what to use. So I've used the MetaQuest 3. I feel like it's a pretty solid choice here. It's pretty commonly used for social VR and has wireless standalone rendering as well, which makes it a bit more accessible for user studies. Then I've been using the Unity game engine, which I'm very familiar with, so it allows me to do rapid iteration, and it's also very efficient for this kind of XR rendering as well. I've been using the OpenAI real-time API, which allows me to kind of encapsulate this pipeline from speech to text to LLM query to text to speech as well. And it does it really efficiently. I experimented with different models of text to speech and speech to text and going to different LLM models, but using the OpenAI real-time API, at least at the time, seemed to perform the best. So I've stuck with that. And I'm using Basis VR as a framework for making the networking work for the back end of the actual social VR platform itself. Basis is pretty great. It's open source and has a fantastic community that's really eager to help people learn. I don't have a whole lot of experience really with networking, so this has been really useful to use. Great, so for the prototype, this was kind of the basic architecture I came up with. So you can see on the left is the user, and the right is the embodied conversational agent. The user will speak, so speech to text goes to the bot, and the LLM then will query some kind of response based on that, and then it will output some text to speech. So the user will get send speech themselves, and they will hear audio in response, kind of like a real conversation. Here's a bit more of a complex architecture of what's going on under the hood right now with the prototype. So there's kind of not just the LLM that's being considered here. There's also other aspects like the actual 3D renderer and animator of the body of the ECA. There's also the navigation module for it to be able to walk around the environment. There's also the memory module. So there's a few different things that are considered here as well. And as I develop this, that will just get more and more complex. Great, so I don't really have a video right now to show you, unfortunately. However, I've got it to the stage where the environment doesn't look too good. It's kind of a bit rushed, but it works, and I have the ECA that works right now. I've tested it a bit on my Quest 3 headset. It runs in real time, pretty fast, and it walks around and can interact with the environment. And so, for example, right now, the only kind of contextually aware commands it has is that it can, if you're walking around the forest, as you can see, and you tell the bot to stop, like say, stop following me, it'll go, okay, and it will check its memory to see if it's actually following you, and then it will decide to stop and then update its memory accordingly, and will actually stop following you as well. So from here on, I have a few other future directions that I want to do. So with this prototype finally kind of done for the most part, I'll put that to the side for a second, and I want to actually investigate user perceptions of and what they want from ECAs through a questionnaire that I'll be submitting online and passing that around at some point in the near future. So if you're interested in helping out with that, that would be super useful at some point. After that's done, and I have a bit more of an understanding about what people think about this technology, then I'll go back to the prototype, start developing it a bit more into a finished agent. And by finished agent, I just mean one that's good enough for doing the user studies, because I could work on this forever, I'm sure. And then through user studies, I want to investigate the different impacts that complex behaviors and different features of the ECA would have on user embodiment as well, in more of a one-on-one social interaction. And then finally, in my maybe third year of my PhD, I will be looking at more complex social settings and more complex behaviors there. For example, using the ECA in the context of group interactions or different power levels in social interactions, or even longitudinal studies to see if repeated interactions has an effect on how people interact with this. Great. That's all. Thank you so much for listening, and I'm happy to take any questions.
Thank you so much, Sam. I can go ahead and share my screen and talk about the other two sections of the agenda, if that's okay.
Perfect.
All right, sounds good. Let me go ahead and do that. All right, let me know when you see my screen.
Yep, I can see it now.
All right, sounds good. So just to give everyone a quick rundown of what's gonna happen after this, based on what you heard during Sam's talk, we can have a Q&A session, so you can ask about his research, projects, any like technical or non-technical details, leadership at ICXR, or anything else that's related to the theme and event. Soon after that, we will have a paper discussion. So I have posted a sample post or entry in the research channel, but you can use the research thread, which is right here under Learn on the Discord server. And you can go ahead and share a paper that is relevant to today's topic of avatars and agents in social VR. And you can quickly just describe what the paper is about, send us a link, tell us what contents it was published at, and if there's anything interesting that you would like to talk about. After that, we will kind of just conclude everything, so I'll go ahead and stop sharing my screen so we can move on with the Q&A portion of today's event. Okay, so we can officially just go to the Q&A portion. I see Ali Reza raised his hand, so do you want to go ahead and unmute? You should receive an invitation to speak, by the way. If you are having trouble using your mic, you can also type the question in the discussion chat for this event, and I think that might be easier. But I have also sent you an invitation to speak, so yeah.
Do you hear me?
Yes, we can.
Oh, okay. Thank you. Sam, thank you so much for the great presentation. Just wanted to ask if it's possible, please share your slides in the chat with us because I joined a little late and I missed some of the slides.
Yeah, absolutely. I'd be happy to.
Also, I'm working on computer vision, as you may know, and I'm trying to combine computer vision into MR so that we can have scene understanding, 3D understanding of the environment, I mean, in the MR application. So maybe we can just somehow collaborate in future to add your agent into my AI-based application. So
yeah, that'd be really interesting.
Yeah, it's like we have someone connected to AI that is talking with us, answering our question, and something like that. That would be great.
Yeah, I'd love to look into that.
Thanks. Again, thank you.
Thanks.
Thank you for your question. I have one myself. Quickly, I was wondering what the latency of the LLM is like when it comes to conversations, because I've worked on a similar project in the past, but our latency back then, it was like GPT-3 or like one of the older versions, so it was relatively bad. So I'm curious how you have tackled this issue.
Yeah, that's a good question. So I haven't got any specific numbers in terms of latency that I've tested. However, I've found that it's more of not so much an issue now of latency in terms of how long it takes to compute everything. It's more of an issue of the LLM doesn't actually know when you stop talking. So when we speak, right, we have these pauses in our speech that sometimes are longer than others, but most of the time we're pretty good at telling when someone's actually done speaking, and then it's the other person's turn to start speaking, or if the person's just kind of having a pause. And the LLM's not quite very good at that just yet. So there's a bit of a delay built into the system just to kind of double check that you're actually done speaking. It's at the point right now where you can turn this down, and I've played around with it a bit, but if you turn it down too low, it's very responsive, but to the point where it starts interrupting you because it thinks you've stopped talking. So right now that's kind of more of an issue, at least in the system that I'm using, than just compute power that's too slow.
Yeah, that's interesting. I think a lot of voice assistants like Siri or Alexa have a trigger command and they kind of detect once you have a pause in your speech. So I suppose that could be one of them, but also it's not very realistic, to be honest. So,
Yeah,
yeah.
exactly. Yeah, but then you have the issue of what other alternative is there, because you could always have it in a system where you like explicitly tell them the AI that you're finished talking. But if you do that, that's not really realistic to how people talk in real life anyway. So it's also not a great solution there.
All right. Yeah, I think that's a interesting challenge or topic by itself. So, yeah, that's interesting. I see YCCC VR Lab also raised their hand, and I can go ahead and invite you to speak as well.
Hi Sam, thanks for the presentation. I loved it. I have you talked a bit about the rubber hand illusion, and embodying your avatar and stuff like that. I'm wondering if you've looked into what I've seen called the VR phantom sense illusion, where people who spend a lot of time in VR start to gain a bit of a phantom sense of the world around them, feeling things that are happening but not actually happening, similar to the rubber hand. Wanted to know if you've looked into that at all.
I see. I've heard of that before, and I know what that sense is, but in terms of a research context, I haven't looked into it too much. But I think that'd be interesting though, because I wonder if that kind of applies to embodiment, or if people that are more susceptible to phantom sense, I guess, have a higher correlation with embodiment in the similar way to how my study showed that people with extroversion and personalities have a higher correlation. So that'd be really interesting to look at. I haven't done anything myself or seen much research on that topic, but I imagine there would be something out there. Be more of just finding it, I guess. Yeah, that's a really interesting thought, though. Thanks.
Yeah, I think one of the things that I see a lot in the VR lab here is I've seen like the ghost hand experiment and the VR phantom sense, but the most prevalent thing is it's that uh, first timers in the headsets usually are worried about like stuff like motion sickness and when they're in the headsets, I do notice a sense of they're starting to feel the world around them and react to it, whereas it's that immersion sense of it um, really embodying that experience. So I'd love to see where this your research goes and further on actually being able to embody the character more, the avatar, and kind of make that a more seamless experience and easier transition for users coming into VR for the first time.
Thank you. Yeah, and that's a good point. I imagine there's lots of research as well on that specifically that would exist right now. But yeah, I think I wonder if there is a way of kind of using this embodiment concept for reducing things like motion sickness. That's a really good point.
Yeah, thank you for your question. Do we have any more questions? We do have some time, so. There is a question in the chat. It says, "Hi Sam, what have you found was the biggest challenge for you personally during this particular research?"
That's a really good question. I would say it's hard to pick one, I guess. I would say, though, that at least in my research overall for my PhD, the hardest part has actually been picking something, like picking some topic and sticking with it. So I found this topic now, thankfully, but it wasn't always the case where I feel like, especially in such a fast moving field like VR, there's so many different things you can pick. And it's more of a question of not where is the research gap, but which research gap do I actually want to invest my time in and do the PhD in. I could pick so many other options there that weren't as appealing to me. So I was really fortunate to stumble on something that is novel. I mean, I hope, at least to my understanding, is novel, but also really interesting and super fun to work on as well. So I'd say that's probably been my biggest my biggest challenge for this research. For this specific topic, though, if that's what you mean, then I'd say probably just finding the technology that I can actually build upon for this. Thankfully, in the end, I've kind of used OpenAI's API, which I feel like is also the first instinct that people might have when creating something like this, to just simply use, ChatGPT or whatever. However, it was after a bit of experimenting that I came to that conclusion. So it was kind of funny where I was like, oh, if I had just used this most obvious bit of software in the first place, then I would have already had the best one. So that was a bit of a challenge where I experimented for a while, and there were some times where it wasn't looking like it was going to be feasible to even make this run on standalone, let alone be fast. So I've tried a few different things there, and that was probably quite a big challenge as well.
Thanks for answering. Do we have any more questions? I think we have time for maybe 1 to 2 questions, and we can move on to sharing papers. All right, I don't see any raised hands, uh, nor do I see anything in the chat, so I think we can move on to the next segment in that case. So I can briefly introduce what we will do right now. So the goal is to talk about XR research papers pertaining to today's theme of agents and avatars in social VR. So if you have a paper in mind that you would like to talk about, then you can go to the research thread and post it right there. I have a sample uh, paper that I posted that I can link to in the chat as well. And if you have a paper, please feel free to raise your hand and we can go ahead and talk about it. But if not, I have a paper in mind in the meantime, and you can possibly look around and listen to me talk. But I was looking at this paper from Kai 2025. It was very interesting, and it's about the different types of avatars you can have. So one of them is point cloud of your what you actually look like. So just a point cloud visualization of yourself. The other was photorealistic, so it looks like you. It looks very similar to you. The third is personalized, so you kind of get to personalize your own avatar. The fourth is comic, so it just looks like a comic character. There is, they just call it H, but it's just a single color avatar, just one color. There is no facial features, there's no fingers, you kind of just see the outline. There is a rectangular and there's a round version. And lastly, there is a particle cloud, so you just have a bunch of particles to represent a person. And really quick, the idea is to see how each of these types of physical representations of avatars affect different scenarios and how users interact in those scenarios. So there's negotiation, there is playing a game, and there's talking about perhaps a more serious issue. And I thought it was very interesting. I can quickly talk about the results and open the floor to everyone who has some thoughts on this. But I thought it was interesting that the photorealistic avatar is the one that scored the most. So I think the ranking goes overall. It's almost like photorealism, personalized, comic, kind of like the humanoid, the single color avatar with no faces, and then point cloud and particle cloud. So I thought it was very interesting, and it kind of goes back to the Proteus effect of how you perceive yourself and what you think you look like or what you kind of identify with. So it doesn't surprise me too much that the photorealistic avatar is the one that is ranked 1, but I am surprised that point cloud is not as highly ranked. So I thought that could be an interesting discussion point.
I guess I wonder if it comes down to that aspect of behavioral realism that I was mentioning as well, where I feel like something that's made of a point cloud, even though it might look realistic, as soon as it moves, that movement might be pretty unrealistic there. And that might be quite jarring for some people. So maybe that's one of the reasons why it wasn't as high.
Yeah, I think that makes sense. I would also assume some sort of technical latency related factors. But yeah, I think that makes a lot of sense. Does anyone else have any sort of discussion points on this topic or area? Please feel free to raise your hand or just type in the chat.
I guess one question I have is, do you know how what that motion would have looked like for the point cloud? Because I'm looking at the paper right now, and it seems like there is like the photorealistic and personalized ones that are decent quality in terms of visual fidelity. But the point cloud one, I think even in the image, there's a chunk of the person's face missing, which is probably just the VR headset. But I wonder how that movement would have looked.
That is an interesting question. I have not, I'm not sure if they have a video to watch. They probably might, because I think this paper won Best Honorable
Oh, wow.
Mention or something like that. So I'm pretty sure they have a video, but I assume the visual cohesiveness or cohesion is probably also a factor. Because going in, I was expecting Point Cloud to also perform decently well.
I guess as well, I wonder why the personalized avatar, even though it seems like it's the same fidelity of the photorealistic one, has such a lower score compared to the photorealistic avatar. And some of the metrics. I wonder if it's a similar thing to what I found in my experiment, where some people just don't like looking at them like a kind of creepy, low fidelity version of themselves, as opposed to more of a generic avatar.
I think that can be a factor, but I suppose what is interesting is if you think about it, the photo realistic and personalized look relatively similar, but maybe the personalized looks strange enough for you to think, oh, that's not fully me, so it doesn't feel as creepy, perhaps.
Yeah, exactly. And you might not be able to tell if it's someone else.
Yeah, I think that's an interesting point as well. I'm trying to look at the humanoid ones really quick before. If anyone else has a paper, please feel free to just raise your hand. In the meantime, we can just talk about the one we have. But you can either add it through. You can add it to the thread as well as just raise your hand or put it in the chat and we can talk about it. But on this topic, we have about 5 minutes until the end of the event, so we can have a bit of a discussion. I think it's interesting that the humanoid with edges also performs better than the humanoid with rounded or more cylindrical body compositions. And I think it's interesting. I'm kind of curious as to why the researchers chose two visual formats of the same avatar type or like the humanoid type. I think that's an interesting thing to think about in the first place, and also the results.
Yeah, I wonder, looking at again just at the image they have of those two different avatars, the edges one looks more human to me in general, where the round one looks a bit more cartoonish. in terms of the overall body shape, not just the fact that it's got less sharp edges. So I wonder if that was one of the things as well. Is I don't know how well the round avatar would have lined up properly with people's tracking of like their hands and stuff. I wonder if that's partly why, or if it's just because of the edges or not.
I think that could be a factor for sure. I think when I looked at the rounded humanoid avatar, I was kind of thinking of an ogre and less so a human. So that
Yeah,
could
exactly.
definitely play a role. Mm-hmm.
Yeah, I think as well, it seems like it just has less detail than the edges
Okay.
one. So maybe that perceived detail kind of makes people think it's less like a lower quality avatar, but who
Yeah,
knows?
I can see that point of view. Mm-hmm. I don't find it surprising that Particle Cloud was ranked the least because it is kind of common sense if you're in this field that having a face or physical features is better than no face and just a skeleton, which is probably better than like just a particle cloud. So I think that's fine, but I do think the other results are pretty interesting to think about.
Yeah. I mean, it's tricky to feel like you're embodied when you just have a particle cloud kind of
Right.
flying around you as opposed to actually uh, belonging to you. I guess it kind of goes down to the aspect of body ownership as well in embodiment, where at least with the other avatars, it's probably a bit easier to be like, okay, this is my body as opposed to this is some abstract cloud of particles moving around.
Yeah, I can understand that as well. I before I talk, I'm curious if anyone else has any thoughts on this paper or just any other paper in this research topic.
If not, as well, I've also posted another paper there. It's maybe if we don't have time today to talk about it too much, I'd still encourage people to have a look at it. It's really interesting, I find. It's a systematic literature review of embodied conversational agents in XR. So not so much focused on social VR that I've been for my research, but it looks at different aspects of these ECAs over the whole context of AR and VR, and find some really interesting results as well. So I'd encourage, if you're interested in this topic at all, it's definitely a good paper to check out. And it's pretty new as well. So I found it quite useful myself because it actually talks about more recent papers in such a fast moving field. It's quite useful right now.
Yeah, thanks for sharing. We do have
I can
about
also
3
share my
minutes.
slides as well.
Mhm.
Oh,
Of
sorry.
course, thank you. Yeah, so we do have about 3 minutes until the end of the event. So perhaps, yeah, if there's any last minute thoughts about the event, Sam's presentation, any other last minute question you didn't get a chance to ask, or if you just want to talk about a paper, then yeah, feel free to raise your hand or put it in the chat box. But if there are no questions or comments, then I think we're kind of coming to an end. Do you have any last remarks, Sam?
Just thank you everyone for coming today. It's been a pleasure and a privilege to be able to present my work. I find it really interesting, so I hope you guys did as well.
Yeah, it was very interesting to hear from you, so thank you for presenting as well. And I think we can kind of conclude almost early. Shiri says, I wish I was home so I could spend more attention. No worries, you can. We are recording, so you can go back and watch it once you have time. And we also have that research thread, so you can pop by as well. So, yeah, thank you. All right, I think we are getting close to concluding the event. I just wanted to say thank you everyone for joining. We will have more events as part of the ICXR research series, and yeah, please keep an eye out, and we'll have some other amazing guests that you can talk to as well. Thank you.
Thank you very much. Have a good night.